So we've already talked about arithmetic sequences earlier this year, and today we're going to be moving on to geometric sequences. A geometric sequence is just a sequence where the ratio between consecutive terms is constant. In other words, if you divide like the one term by the term before it, you keep getting the same answer every time. So, in other words, 4, 12, 36, 108, it's a geometric sequence with a common ratio of 3. So, two ways to look at that. One, you could think to get from the first term to the second term, I'm just multiplying by 3. And then I keep doing that again and again and again. Or you could actually take two consecutive terms and divide the later one by the earlier one, like 108 divided by 36, that's 3. 36 divided by 12, that's 3. So these are two ways to think about what your common ratio is. So this common ratio is 3. I want you to try it this time. On your own, can you write a geometric sequence with a common ratio of 1/4? So just try to do it, and I'll give you a couple examples of things that might be right. Okay, so you can start with whatever number you want. Maybe it might be nice if it's a multiple of 4 of some sort, so it's a little easier to do, but I might say 80. If there's a common ratio of 1/4, that means I'm multiplying by 1/4 each time, or dividing by 4 each time. So it goes 80, 20, 5, 5/4, etc., etc., etc. Okay, you could have started with whatever number you wanted. So say you did 16 divided by 4 is 4, or multiplied by 1/4. Multiplied by 1/4 is 1, times 1/4 is 1/4, etc., etc., etc. Okay, so what's important, if your common ratio is 1/4, you're multiplying each consecutive term, it will be times 1/4 the term before it. Okay, so I want you to find the common ratio of each sequence here. So try these both on your own. Okay, so A was 3, negative 15, 75, negative 375. So the way I usually like to look at it, if it's easy, is it looks like each time it's multiplying by negative 5. So my common ratio equals negative 5. And if you had a hard time doing that, you could have just taken two consecutive terms and divided them, like negative 375 divided by 75, that's negative 5. And that should work every time. If it's truly a geometric sequence, every single pair would have the same common ratio. Okay, so this time in B, to get to from 3 to 3/2, I'm multiplying by 1/2. And to get to 3/4, again, I'm multiplying by 1/2. And to get to 3/8, again, I'm multiplying by 1/2. So it looks like in this case, my common ratio equals 1/2. Okay, again, if you take any consecutive terms and actually divide them, like 3/2 divided by 3, you would get 1/2. Okay. All right, let's take this a step further. So I want you to think about the common ratio, but now this time I want you to actually be able to produce the next 3 terms. So I'll see if you can do this with no guidance from me. Okay. So it goes 5, negative 10, 20, negative 40. Make sure you're trying this without me. Okay, so first step, try to find the common ratio. It looks like it's multiplying by negative 2. So each time we continue to multiply by negative 2, I should get 80, negative 160, positive 320. So see if you got that one. Okay, the next one is multiplying by a decimal, but don't panic too much. Okay, so if you're having trouble seeing what it's multiplying by, just try dividing. Like 225 divided by 150, we get 1.5. Okay, so it multiplies by 1.5 every time. So if I continue that, 225 times 1.5, we get 337.5. Okay, then multiply that by 1.5, and we get 506.25. And then multiply that by 1.5, we get 759.375. So those are the next 3 terms of this sequence. Okay. All right, so what I want you to do now is determine whether each sequence is arithmetic, geometric, or neither. You might need a little refresher on what an arithmetic sequence is. An arithmetic sequence, remember, that was when we added the same number every time. We said there was a common difference. Geometric, when you multiply by the same number every time, we call it a common ratio. So I can write like add multiply. Neither would be if there's not a common difference or a common ratio. There still might be a pattern that you can find. So here's the first one. 162, 54, 18, 6. So I'm going to look, is there a common difference? Is there a common ratio? So to get from 162 to 54, one thing that I could do is subtract 108. To get from, if I do 54 minus 108, I obviously do not get 18, so that's not arithmetic. To get from 162 to 54, I could also divide by 3, which is also known as multiplying by 1/3. To get from 54 to 18, I could also multiply by 1/3. To get from 18 to 6, I can also multiply by 1/3. So because this is a common ratio, we will call this geometric. I'll just write a G. Okay, this one. 98, 101, 104, 107. So again, I'm going to try arithmetic first. It looks like I can add 3 here. Oh, yay, I can add 3 here. I can also add 3 here. So in adding a common difference of +3, that works every time. This is an arithmetic sequence. Okay? So this one, 5, 6, 8, 11, 15. So if I try adding here, I could add 1 from 5 to 6, but then I have to add 2 from 6 to 8. So it's definitely not arithmetic. If it's geometric, to get from 5 to 6, I could multiply by 1.2. To get from 6 to 8, I'd multiply by 1.3 repeating. So it's not the same number, so it's not geometric either, so this is neither. But if you notice, the patterns add 1, then add 2, add 3, add 4. So you could produce the next few terms of this by figuring out the pattern, but it's not arithmetic or geometric. Okay, so what I'm going to ask you to do next, this is the hardest part of the lesson. It's the tricky part, but it's kind of fun if you can actually figure it out. So I'm going to look for if you can figure out a formula. So if you can actually see what you're doing here. So what I want you to do just on your paper is write the first 4 terms of a sequence that begins with 10 and has a common ratio of 3. So it has to start with 10 and have a common ratio of 3. So I just want you to write it out. Then your job is to write each term using repeated multiplication. So what I mean by this, so if I start with the first one, I've got 10. Okay, I multiplied by 3, so I've got 30. And multiplied by 3 again, I have 90. If I'm doing that using repeated multiplication, when I have 10, I just write 10. Then to get 30, I did 10 times 3. Then to get 90, I did 10 times 3 times 3. Okay, etc. So you see my flow there. Okay, so go all the way to the first 4 terms. I guess I already did 3 for you. Okay, and now what I want you to do is write each term using an exponent. Okay, so I'm going to go ahead and do this again. I'll finish this out. So times 3 again, which should be 270. Times 3 again should just be 10. Times 3, times 3, times 3. Okay, and if I wrote those using an exponent, and I'm not going to use an exponent for my 10, I'm going to use an exponent for my 3. So it looks like I just start out with 10, and then this is, the second one is 10 times 3 to the first, and then it's 10 times 3 squared. And then, if I can squeeze that on, I'll just write underneath. That's 10 times 3 to the third. Okay. I want you to notice what's happening here. See if you can find out something. So we start with our base number, and then we take our common ratio to a power. And so this was my 4th term. I took it to the 3rd power. My 3rd term, I took it to the 2nd power. My 2nd term, I took it to the 1st power. So I want you to try to write the 20th term using an exponent. Okay, and I will give the answer. I just want you to see if you can get it right. So it's going to start with a 10 just like it did last time, but then I'm going to multiply it by 3 repeatedly, a lot of times. To get to the 20th term, I'm not going to multiply it by 3 20 times. I'm going to do 1 less than 20, just like my pattern showed above, and it's going to be 10 times 3 to the 19th. Okay, so here is the basic formula for any such situation like this. A geometric sequence can also always be represented in this format. A of n, the n, that's just known as your nth term, will be a times the common ratio to the power of n minus 1, because you're multiplying it so many times, but you didn't have to multiply it the first time, so it's n minus 1. So if we're looking at this, I want you to find the first, fifth, and 10th terms of this sequence. It has the rule a to the n equals negative 3 times 2 to the n minus 1. So what I want you to notice about this rule, this is my first term, and this is my common ratio. So if I just started listing, I could do negative 3, and that's going to multiply by 2. So negative 6, negative 12, negative 24, etc. like that. Negative 48. So if I'm not asked for something that's very big, like the first term is definitely worthwhile just doing that. The fifth term, I got there pretty easily as well. But if I ask you to find like the 100th term, you would definitely want to actually just be able to evaluate it. So the first term is negative 3. It looks like my fifth term is negative 48. Okay. And then my 10th term, when I look there, this time I'm going to actually plug it into my formula. So I'm going to do negative 3 times 2 to the 10 minus 1, which is going to be 9. So I'll probably want my calculator. Okay, so 2 to the 9th is 512. And when I multiply that by negative 3, I get negative 1,536. So that would be the 10th term. So you see it grows very fast. All right. Looking at a couple more, I want you to write a rule for the sequence that begins 1,250, then 500, 280, and then use your rule to find the 8th term. So the first thing we need to do here, so we need to do the first term times the common ratio to the n minus 1. So the first term is really easy to find. That's just 1250. So I'll write the a of n equals common ratio. This time is a little trickier because it's maybe not obvious to say, hey, what do I multiply 1250 by to get 500? So remember, you can just do 500 divided by 1250 if you want. And you can see that the common ratio is 0.4. Okay, so to the n minus 1. If I'm trying to find the 8th term, I'm going to go to the 7th. So I'll do 0.4 to the 7th power times 1250. And again, I'm going to want to use a calculator for that. And it's not going to be the prettiest number. Well, it's not that bad, actually. It equals 2.048, and I didn't even have to do any rounding. So that's the 8th term. All right, if I look at one word problem, see how you can do here. All right, so suppose you drop a tennis ball from a height of 2 meters. So here we go. It starts at 2 meters. On each bounce, the ball reaches the height that is 75% of its previous height. So here we go, 75% of what it was. Okay, and I want you to write a rule for the height the ball reaches on each bounce. In centimeters, what height will the ball reach on its third bounce? So what we need to do is just some semantics here. I think a case can be made either way. So we just need to decide if this is our first bounce or if this time is our first bounce. And I'm just going to say our initial height, we'll call that our first bounce. Okay, since the bounce is really in between the peaks. We'll just, for this problem, we can call this the first bounce. So it's going to start at 2 meters, and then it's going to multiply by 0.75 every time. Okay, so since I'm calling this initial one the first bounce, it's only bounced 2 times to get to the third bounce, so just like our rule, times 0.75 squared. So if we do that, I'm going to get a height of about 1.125 meters. Okay, and so you just want to be cautious if the problem tells you like only after a bounce is that considered the first bounce or whatever, so that you know it. Okay, so closure. Without looking in your book or in your notes, I want you to write a geometric sequence and write its rule. And then see if you can write an arithmetic sequence and then write its rule. Okay, show these to me. Okay, so come in and show these to me. And I want a conference with you and see if you are right. All right, have a great day.